Right, so make sure that your calculator is in degree mode for law of sines and cosines questions. And these first few questions are a review of law of sines and cosines from our last lesson. So just to warm up and help our people who are not here, we have a triangle that's drawn for us, and they want us to find, and this is how it's going to look on your test, where they just want you to find like one part of the triangle. So they want you to find segment RT, which is across from angle S. So I'm going to go ahead and call that S, because that makes sense to me. And I look at this triangle, and I have an angle side setup, which if you remember from our notes on Friday, that meant that we're going to be using law of sines. So I look for the part of the triangle that is all filled out, which for us would be T. We have angle T and side T. So you're going to start law of sines by saying the sine of 29 over 41 equals, and then we're trying to solve for leg S, so we should use this part of the triangle next. So the sine of 33 over leg S. So on your calculator, you're going to multiply the diagonal that has no variable. And then remember the shortcut is you're going to divide by that other trig function over here. If you think about cross-multiplying this proportion, you would have ended up with, 41 times the sine of, you don't have to write this part out, sine of 33 equals S times the sine of 29. So in order to divide to solve for S, you'd have to divide by the sine of 29. So after your previous math life and you had to solve a whole bunch of these in a row, you started taking some shortcuts, and I would like you to utilize those shortcuts. But can someone tell me what you get here so I don't have the wrong answer? Because I feel like my answer is way wrong. Oh no, it's right. Okay, I was looking at the wrong question. 46, there's no label on it, so 46 units, whatever that is. Now this next question, they want me to find the measure of angle B. And we have a side setup. So if you remember from your notes on Friday, side means that you're going to set up law of cosines. So law of cosines is the one that looks like a really elaborate version of Pythagorean theorem. And since they want you to find angle B, you're going to use the version of law of cosines where you have to use angle B. So that would be the B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. So I mentioned to you guys on Friday, the very first question, 2 questions on your test on this section is to write down law of cosines formula and write down law of sines formula. Just one version of them, because that's not on your formula sheet. So if you're having a conceptual mistake on the formula, at least I can kind of follow your work after that. Hopefully that's not the case. All right, leg B is 10. So we're going to plug in our numbers. We have 10 squared equals, and then your other 2 legs can go in any order, but it's 5 squared plus 7 squared minus 2 times 5 times 7, and then times the cosine of your angle. So remember, we don't know the angle, so that's going to be our variable. And the way we solve these questions, these are the ones that are kind of tricky to type on your calculator, so I need everyone practicing how you type this. You start with the current solution, which is 10 squared. And then how are you going to move this 5 squared and 7 squared over to the other side? You're going to subtract them. So go ahead and type 10 squared minus 5 squared minus 7 squared, and then hit enter. And then you have some number on your calculator, whatever that is. Then you're going to move, excuse me, the negative 2, 5, and 7 over. They're attached with multiplication right now, so that means you're going to divide each of them over. Make sure you're dividing by a negative 2, not just a 2. So divide by the answer by negative 2, 5, and 7, and then hit enter. And you should have a decimal. And it better be smaller than 1, otherwise we've done something weird. Could be between negative 1 and 1. And then finally, to undo the cosine function, you're going to apply the inverse cosine to the answer. And you should come up with a value for angle B, which I got 111.8 degrees. And I get a confirmation on that. Excellent. Okay. So that's just a couple quick examples of one law of sines, one law of cosines. We talked in great detail, actually, about the ambiguous case on Friday. So those of us who are gone, we need to go back and look at that lesson about the ambiguous case as well. Let's go ahead and do number 4, though, because it is going to be a little insight into what your homework for tonight is going to be. By the way, when you walked in, you picked up 2 papers. You picked up a review for the next test, which is Wednesday, and then you also picked up a revisiting 4.3. I feel like a good chunk of us need to retake 4.3, and that's a really big topic coming up for us in the next few lessons, and in general. So probably tomorrow I'm going to do some of those with you, but if you know like you're the kind of person who's in need of a 4.3 retake, I suggest you do that worksheet sooner than later, and if it's a matter of coming in for help, then go ahead and come in for help right away. All right, so back to this, number 4. We have a picture that's drawn for us, which is awesome, because when the pictures are not drawn, it's terrible. And they have a lamp post that's tilted 2 degrees from the angle from vertical. So let's go ahead and figure out this angle here. If it's not vertical anymore, which would have been a 90 plus the 2 degrees, that means this angle is 92 degrees. And we have angle side angle, which means we're going to be using law of sines in this question. Unfortunately, however, they didn't give us everything, but that's okay, we can figure it out. So they want to figure out the length of the lamp post, so I'm just going to call this x over here. So I know that's going to be one side of my proportion for law of sines, but the only other clue they give you is that the side down here is 25 feet. So in order to use that, we're going to have to know the angle across from it. I think you guys secretly do know this angle because you know triangles add up to 180, right? So 180 minus 45 minus the 92 you just found is 43. So this angle right here is 43 degrees. All right, we are ready to set up law of sines. You start with the part of the triangle that's all filled out. So for us, that would be the 43 degree angle and the 25 feet. So the sine of 43 over 25 equals, and then if you're trying to solve for x, you're going to use his angle. So sine of 45 over x. So on your calculator, cross multiply, and then you're going to divide by the sine of 43. And then, you know, sometimes I make up these problems. They don't make tons of sense, but this was not made up by me, so it should make a little bit of sense. An answer of a lamppost being like 26 feet tall is not unheard of, so go with it. If you're doing your math weird and you got like the lamppost is like 1.3 feet tall, you might want to rethink what you've done. Something's weird. All right, so next question. This is the new stuff. So we did not get a chance to discuss area formulas. There's 2 area formulas which are given to you on your formula sheet. They're kind of in a weird spot though, like one might be sideways. I forgot, we had to like fit it on there. So the first area formula is the one that you're going to use when you have a side-side-side situation. It's called Heron's formula, named after Heron. And if you have all 3 sides, what you're going to first do is you're going to calculate what's called the semi-perimeter. So the semi-perimeter is half of the perimeter. So you find the perimeter and then you cut it in half. And then what you have to do, and this is kind of weird and you don't have to understand why it works. Good old Huron did that for you. It's the square root of the semi-perimeter and then times all of the legs taken away from the semi-perimeter. Again, just live in the mystery that Huron was a really cool dude who figured this out. When you go to college, they have you derive all these formulas if you become a math major. So look forward to all that. Super fun. All right, so let's look at what this question looks like when you actually execute it. And I'm going to show you a little shortcut on your calculator if you want to use it in a moment as well. So this question, I don't think is on your notes. It's already done for you on the slide though, so just kind of look. We have a triangle, and all 3 sides are given to us. So the first thing they did was they found the semi-perimeter. So the semi-perimeter would have been half of the perimeter. So once they calculated that, they got 67. And then they went to their formula, right here. Whoop. And underneath the square root, they have the, notice how many times the semi-perimeter shows up. The semi-perimeter times the semi-perimeter minus the first leg, minus the second leg, and minus the third leg. Order doesn't matter here, obviously, because it's commutative property. You don't have to do any execution in your head. This is all on the calculator, and you're going to get an approximate answer, because it's usually a nasty number, of 827 square inches, and that's the area of that formula. So the shortcut that I want to remind you of is that your calculator can store values. So some kids like this because it's just less typing, and some of us find that on tests we're a little sloppy with the typing. So just to remind yourself that your calculator can store values in the home screen, can you all pretend like 67 was the semi-perimeter, which it just was, and type 67 and then hit the stow key, which is right above the on key. And then I always use the variable key for X, like the one you use when you go to graph. So like the one up next to alpha. And then once you hit 67, store as X, and then hit enter, then it thinks X is 67. So then what you're going to do on your home screen is you're going to type the formula, but instead of having to type 67 every time, you're just going to type X. So if you find like that's worth your time, and sometimes the semi-perimeter is a decimal, so maybe in that case for sure I'll use store. I don't really know how much time we saved storing 67, but you know, whatever makes you happy. Can y'all practice typing that though? Yes, you need the rest of the question. There you go. Oh, it doesn't matter. So in the home screen, X is always something. So if you're trying to use X in the home screen, you're going to have to overstore it. But you usually don't store anything for X. When you're in the Y equals screen, it views it as a variable. So at any point, like today, if you never store anything else for X and you happen to type X on your calculator, it's going to pop up 67. So if you, in the future, you want to use the storing feature again, you'll have to store the number, whatever you want to use. So like 23 stores X. It's not going to affect any of your math in the Y equals screen. Does that answer your question?
So it won't affect the graph at all?
It won't affect graphing at all. Huh. Are you taught? So hopefully you all practice that and you can figure out how you too can get 827 square inches. All right, so this question, you know what? Let's try storing. Let's see if we like it. First thing you have to do though, guys, is find the semi-perimeter. So the semi-perimeter would be a half of your perimeter. So this one I think comes out to 15.5. So if you want to try using the store, what you're going to do now is type 15.5 and then hit the stow key and then X. And if you're doing that, then the next thing you're going to type on your calculator after you hit enter is square root of, I don't know why I made that so big. Square root of X times the quantity, let's see, X minus 36, X minus, what? Did I do something wrong? Is that not the semi-perimeter? That doesn't sound right at all now that I look at the question. For Pete's sake. What's the semi-perimeter? Oh yeah, it's right there in front of me. Why do I keep looking at the wrong question? Okay, so like I said, store X as 39. I was looking at this going, why are these going to be negative? Okay, that makes sense. All right, so X minus 36, X minus 20, and X minus, what's the other one, 22. So moral of the story is it helps if you store the right thing for X. My bad. I think the most common mistake for kids is, well, one, they forget what semi-perimeter means because that is not on your formula sheet, I don't think. And then the second key is this first X. A lot of kids forget to type that first X. Be careful. Anywho, okay, I'm thinking I get 194.4 square inches. What you got? Oh, good. Good call, good call. Okay, spoiler alert. The next one has a semi-perimeter of 15.5. But if you don't mind, guys, I'm okay with skipping the next few questions for the sake of our time because it's just more of the same. So if you like storing, do it. If you don't like storing, don't do it. All right, on the back, there is another formula for calculating the area of a non-right triangle if you have a side angle side situation going on. Now, this one's a little more challenging because sometimes you have to do law of sines before you have a side angle side situation. But I'm looking at these formulas, and these are actually pretty easy to derive. I just don't have time to do it for you right now. But it's 1/2 times b times c times the sine of the included angle. So what's going to happen is you're going to be given an angle, hopefully, and then the two sides that are surrounding that angle, that's your side angle side setup. And then you're going to be able to use whichever version of this area formula that you can use. So this one is much easier to use than Heron's formula, but you have to be given this information in order to use it. So when I look at your paper here, number 8, they don't give me a triangle, so that's dangerous. Let's draw a triangle. Nailed it. All right, so RST, sounds good. It can go anywhere, just make sure you're labeling properly. Angle R is 50 degrees. And then leg S is across from angle S is 12. And then leg T, which is across from angle T, is 14. So we do have that side angle side set up. So we're going to use the area formula that we just saw, which you do not have to have memorized. It is on your formula sheet. But it's 1/2 times the two legs, any order, times the sine of the included angle, which for us was 50 degrees. So getting that typed in your calculator, and you get approximately 64.3 yards squared. Now do watch your labeling, guys. This is area, so you want to make sure you have a unit squared on the end of it. And then number 9 has a star next to it. That can't be good. Let's figure out why it has a star. All right. Triangle. MNP. Sure. Little n, which is across from angle n, is 14. And then angle P is 110 degrees. And then angle N is 25 degrees. So we have an angle side situation, which is neither side 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 nor side angle side, which means we are not ready to find the area of this triangle. However, if we can use our skills from the last lesson, law of sines, we could find one of the sides, and then we can use the side angle side area formula. So it is totally up to you as far as which side you would like to find. Would you like to find side M or side P? I don't care. Side P? All right, sounds good. So find side P using law of sines first. So first thing we have to do is set up. We know everything about N. So sine of 25 over 14 equals sine of, if we're trying to find side P, we're going to use 110 degrees. Okay, so on your calculator, could you please cross multiply and divide this ratio? And I don't think I went this direction, so can someone tell me what they got for this? One more time, I'm sorry. 31.1? Okay. So this is really 31.1. So now we, 0.1. Yeah, you know. Sorry. So we kind of have a side angle side. Except I need you to do a little geo problem for me. You got to figure out how big that angle is, which you totally can. Triangles add up to 180, so 180 minus 25 minus 110 is it 45? Okay. So this angle right here is 45 degrees. All right, here we go. Area formula. 1/2 times. Now you got to be careful. There's a lot of info going on in this triangle. The legs that we're supposed to be using are these guys. And then the angle is the angle that's in between those, which is 45. What'd you get? Approximately. 150 what? I'm sorry, I'm real deaf. Thank you. And then, you know, I solved this a little differently when I originally did it. I found the opposite leg, M. So I used a different law of sines, but then I used a different area formula. Turns out to be the same area, and then because of truncation, I think I even had a slightly off answer, but we all know that's from truncation. So if you're keeping decimals in your calculator and using the answers, that's the best way. The more decimals you keep, the better. Obviously, you guys are going to show your work, so I'm going to be able to figure out what you did. As long as you're in the ballpark. Okay, so those are your two area formulas. I think the second book assignment that I threw at you guys on Friday, the real short one, is basically this. It's just finding the area using one of the two formulas. So make sure you're showing work and you're drawing triangles for those. Now, for the rest of the notes, we have a bunch of application questions. Some of them are more fun than others. So here's the thing for applications. They're probably multi-step problems. So I expect to see multi-step work on your homework, guys. It is awesome if they give you a picture. It is less awesome if they do not. It is extra less awesome if I have to draw your picture. So on your worksheets, which are your homework, we have problems that are selected. And on the answer key, all you have is the answers for the ones that you're assigned. But then surrounding those questions, I went ahead and worked through some of the questions as well. So if you kind of get stuck, you can kind of see what I'm looking for as far as, oh, this is going to be a two-step question. Like I have to find X first, and then I have to go find the height. I even wrote you some hints, I think, on the answer key for today's homework, on the ones that I think are more challenging, that might take 2 or 3 steps, where you have to do like step 1 and then step 2 before you can move on. So please do look at the answer key, and please don't fall into the trap of, I'm just going to write down the answer and hope she doesn't notice, because I'll notice. These have a lot of work, okay? So make sure you're showing that work. All right, let's take a look at this artsy question. Looks fun. I don't know about you, but on the paper, I can't really read it. But on the slide, I can read it pretty well. So if you need to kind of redraw something, you can, but I'm not going to bother. All right, they want to know the area of the yellow triangle. Cool. Turns out the yellow triangle and the blue triangle are the same triangles. So that helps. So this triangle and this triangle are equivalent. Well, guys, I think this is a really easy question then. Because if this blue triangle is the same as this yellow triangle and I need the area, don't you have a, no, it's not easy, I lied. I thought I had side, angle, side. I don't. What do I have? Angle, angle, side. So this is one of those two-part questions where you're not ready to use the area formula. You're going to have to use law of sines first. Okay. If I knew this side right here, I would be in business. I think I can figure it out. What part of that blue, or technically yellow, but this blue triangle do you have everything filled out for? This 45-degree part, right? So you're going to set up the sine of 45 over 6.5. And then this is where you might meet a bit of a roadblock. You're trying to set up law of sines. You kind of need that angle. But it's okay, because you all went through geometry. How do you find the third angle in a triangle? Well, you subtract them from 180, right? So 180 minus 100, oops, minus 45 is it 35? Okay. So that's going to be the rest of our law of sines proportion. Sine of 35 over x. All right, let's cross multiply and divide. And you're going to find that I think it's 5.27. Okay. So now that I know this is 5.27, now I can use that side angle side area formula that we just learned. And I kind of wrote too big. What's new? So my work's going to move down here. So the area is 1/2 times the two legs, which are 6.5 and 5. You can round it to 5.3 if you'd like, but whatever. And then times the sine of the included angle in the middle, so 100. So on your calculator, oh, I got approximately 16.9, but I don't know if I truncated in my math or not. What'd you guys get? About 16.9? Okay, that's good enough. Feet squared. Now this follow-up question is a little bit extra. It says, it takes 3 coats of paint to make a barn quilt. I don't know what they're talking about. It takes 3.5 ounces of paint to cover a square foot. How much paint will be needed for the yellow triangle? So this is essentially a proportion question. These are the kind of questions that really get you ready for your standardized testing, because oftentimes they give proportion questions that are hidden inside of a word problem. So 3 coats of paint, be careful, that'll come in the end. 3.5 ounces to cover 1 square foot. So 3.5 ounces per square foot, and you've got 16.9 square feet. So how many ounces of paint do you need for just the 1 coat? Let's start there. So cross multiply and divide that, or there's no dividing, so just cross multiply that, and you get, is it 59-ish? Okay, so it's about 59, but then remember you got 3 coats of paint. So you're going to say about 178-ish. I did a lot of rounding there. Sorry about that. All right. Oh, this would have been a really cool question for the Super Bowl. The blimp. Do they have blimps anymore at Super Bowls? I don't know. I didn't watch a moment of the Super Bowl. How'd it go? Heard it was terrible. Can you imagine paying that much for a ticket? The music wasn't good either? Oh. That's all you care about? Okay. Oh. Well, I'm glad I didn't waste my time watching it. All right. So the blimp hovers. Oh, it's soccer. My bad. I got excited. That was football. Wrong football. All right. So players are 500 feet apart on opposite ends of the stadium with a blimp between them at the respective angles shown. Angles of elevation shown. What is the height of the blimp? So they put a question mark here. I'm going to one-up them and call that X. And we're not ready to find anything yet. A lot of kids look at this picture and they assume that these legs of the triangles are congruent to each other, and they are not. I know the way it's drawn, it makes it look that way, but they're not congruent. So here's what's going on, guys. You have an angle, side, angle. So if you think about our work from Friday, angle, side, angle lends itself nicely to a law of sines question. If we use law of sines, we're going to be able to find one of the missing legs. Once we find a missing leg, then we're going to break this down into a little baby problem, a right triangle problem. Okay? So which leg would you like to find? It doesn't really matter. This guy over here? Sounds good. All right. I need to call it something, though. Huh? Y. I'm very clever today. All right, let's find Y. So we are going to set up, what are we going to set up? Oh, man. They did it again. They didn't give me the angle I actually need to start with. So a little quick geometry problem, please. 180 minus 63 minus 72. How big is this angle here? 45. Cool. All right, so there's the start of our law of sines question. We have sine of 45 over 500. And then if you want to find what we're calling y, you got to use the angle across from it. So sine of 72 over y. So again, we got a cross multiplication question. It's not too many applications where we have to worry about the ambiguous case, where there might be 2 possible answers, so that's the good news. But I'm finding, what am I finding? 672.5? Cool. Unfortunately, that's not what they want. So that's great news that this is 672.5. So here's what I need you to do. If we need to find the height x, height indicates altitude is another word for it, which means, oh boy, which means you have a right triangle. That thing I just tried to highlight in red is a right triangle. You know an angle, you know a leg, and you're wondering about another leg. That is perfect for a just basic, is it sine, cosine, or tangent though? This is opposite of the angle you're given. This is the hypotenuse. We're looking at a sine question. Now, a lot of kids are so stuck on law of sines, they're like, I'm going to do law of sines again. You can. It's just kind of a waste of your time because you're going to be taking the sine of a 90-degree angle, which is 1, so it doesn't do anything. Anywho, sine of 63 equals opposite over hypotenuse. So cross multiply that, please, and tell me how big x is, which is what they wanted. Is it 599.2-ish? Awesome. So that's a good case, and you have a couple questions on your homework that are almost exactly like that. You're going to look at your oblique triangle that you have to use either law of sines or cosines on first. You're going to find some missing part, and then you're going to be able to move forward and do usually a right triangle question after that. Like I said on your key, I kind of gave you a little heads up, like find x first, find y first, find h first. That indicates it's a 2-part problem. All right, this one's a hoot. There's no picture. All right, it's my moment to shine. Here we go. Mick Big. He's planning a fence. A triangular fence, which I find weird. One side of the property is 75 feet and forms a 38-degree angle with the other side of the property. Okay. That's not straight. That's not even 38 degrees. Pretend this is a 38-degree angle. If you could also pretend that this is 75 feet. Oh, they haven't measured this side yet, so that's unknown to us. We can go ahead and call it a variable. What variable would you like to use? I heard X first, I'm going with it. The remaining side of the property is 95 feet. Cool. It didn't make a triangle. There we go. So it says, approximate to the nearest tenth the length of fence needed to enclose the parcel. So essentially they want perimeter, which means we need to find this missing side. Guys, what do we have right now? We have side, side, angle. Or angle, side, side, which means what to my friends who were here Friday? It is law of sines with the possibility of the ambiguous case. Now, usually on application questions, the ambiguous case is not really something you have to worry about because that means there's two possibilities, but I'm not going to say never. Sometimes it does have two possibilities. So we still are going to set up law of sines, and you only have so many clues to work with. So we're going to start with the 38 degrees and the 95 feet. So sine of 38 over 95 feet. And then the only other clue you have is the 75 feet, which means you're only going to be able to figure out this angle. Now, I need to call this angle something. Can you just give it a name? Y. Okay. All right, so sine of this mysterious y that we don't know over his leg, which is 75. Now, when you're solving this law of sines proportion, this is the one where you have to multiply, divide, and at the end you have to do an inverse sine function to solve. So on your calculator, you're going to multiply this together, and you're going to divide by 95. But remember, you still have the sine of y equals, can someone just tell me what that decimal is before you do anything else? What's sine 38 times 75 divided by 95? Oh, you're so quiet, children. Point. 486, thank you. I heard you cheer this weekend. You're way louder than that. I should demand everything in cheer from now. With a flip at the end. All right, 0.486. So finally, you're going to apply the inverse sine. I know you guys don't normally write out all this work because you just intuitively do it on your calculator, and that's fine. The inverse sine of this decimal is something. 29.1. Okay. Now, my friends from Friday know that we should be like really paranoid about the ambiguous case. It could be 29.1, but according to the ambiguous case, it could also be the supplement to 29.1 sometimes. Well, what's the supplement to 29.1? 150.9. Okay, so here's what I'm thinking, guys. If this angle was 150.9, and we already know there's an angle of 38, that's too big. Your triangle is going to go over 180 right away. So turns out in this case, the ambiguous case is not something we need to worry about. Thank goodness. That means we're almost home free. All right, guys. We got a lot of stuff going on in this question, but we still haven't found what we really need to find, which is that missing side X. So you have some options. You do not know the angle across from it, but you could easily figure it out, and then you could use law of sines again. Could also use law of cosines if you find that angle. You could do a lot of things. What do you want to do? Law of sines? You're stuck on law of sines today? I'm with you. All right, so this was our first problem. So now our second problem is to use law of sines. Can someone do a quick geometry problem and tell me how big this angle is? I got 113. What did I do? 120.9? 112.9. Okay. Is that tight? You've learned from the best. All right, so second step here, we're going to set up the sine, and you can start wherever you want technically, guys, but I'm going to start the same way as our last problem. I'm going to start with the sine of 38 over 95. This time is proportional to the sine of 112.9 over x. And this is super fun, almost done. We're going to cross multiply and divide. This time you just got 2 steps, cross multiply and then divide by sine of 38. And my answer's a little off, so I got about 312, but it's not 312 exact. Huh? What'd you get? Oh wait, maybe the final answer is 312. Maybe that's what I'm looking at. Okay, gotcha. 124.1. But then, yes, she was reminding me that we are supposed to be finding perimeter. So, 124.1 plus the other 2 sides, the answer comes out to approximately 324-ish with some decimal change on there because I didn't round right. Wait, what? 312 is what I meant. I'm done talking today. Okay, what is this answer is what now? 142.1. Okay. Like I said. No? Yes? Okay. It's probably exactly what you said, and I chose to write down something else because I'm a rebel like that. All right, so the perimeter was about 312, right? 0.1. Okay, I'm like out of space at this point. Oh, don't do that. All right, the answer was 312-ish, 0.1-ish. All right, so applications are a super fun time. Here's what I need from you before I see you again tomorrow. Tomorrow, you're going to probably want to ask questions on the review. You're probably going to want to ask questions on some homework problems. Don't let it be like, oh, I haven't looked at this yet and I have 1,000 questions because I don't want to look at them. Your classmates are going to be angry with you. I am not going to record any review video. I have, and I already have posted the answer key to everything. But right now our test is scheduled for Wednesday. Okay? Wednesday. Got a new homework check to work on. Homework checks also due Wednesday. Any issues? I'll be here before and after school every day except for Wednesday morning.